Good morning, everybody. This is Victor Varga from Budapest. Do you hear me? Hello, good morning. Could you just write me a short text message or anything that you can hear that's okay? Yes. Okay, so that we can start now. I'd like to welcome everybody who has joined our webinar. We would like to cover three topics today. The first one is the 203-3. The second is fluorescent light source. And the third is the features of the new scanners of the 1.20. So the Pannoramic 250 Flash 3 is the successor of the Flash 2 with the Flash system to have higher scanning speed. So we nearly double the scanning speed resolution compared to Flash 2. Technical changes on the system are a new camera, a new computer, new scan software. The new camera is from Illumination. Illumination is a Dutch company, and we selected the camera on purpose to have the same chip manufacturer, Flash 2 camera from CI. The purpose was so that we have the same pixel size, resolution, same color, same dynamic range, same noise, so that we provide the very same image quality as we provided with the Flash 2. What we see, the camera intrinsically is a 12 megapixel camera capable of running at 180 frames per second. Just for comparison, previous camera was only 4 megapixels and could run only at 130 frames per second. So, if 4 megapixels in the previous system, right now in the shot we grab or acquire 9 megapixels. We have the full 12 megapixels of the system because the chip is so large that here it will provide the best illumination and image quality. Instead of the full 4,000 by 3,000 pixels, we are only using 3,000 by 3,000 pixels of the current center. And due to the chip size, in this configuration, we have only the 1.6 camera adapter. The 1x camera adapter cannot be used with this camera. And with speed, 40x resolution, what was previously available with the 26x resolution with the 1x camera adapter. Requires a new frame grabber, and this might be important in troubleshooting, installation, and service cases. The older camera was using camera link connection, and camera link is simply not capable of delivering that throughput speed necessary for this camera. Coax standard can deliver 25 gigabits per second. Is required to utilize the full capability of the camera. You can see the difference between the two camera boards. They are all coming from Matrox, the Canadian company. They are all part of the Radiant family. So this is how the Coax card looks, and this is how the camera card looks. To process the higher number of pixels in the same speed, we also have to significantly increase the computational power So we are using a much stronger PC. The new series will be a Fujitsu R940. It uses double Xeon processors and the two processors for 24 cores. The system had a serious RAM upgrade, so we will deliver it with the 32 gigabytes, 128 gigabyte SSD for the operating system, and 1 to 2 gigabyte hard drive for the slide storage. Here is the most important part. So with the new 40x resolution, what is 0.20 micrometer per pixel, we can scan 54 slides per hour, not previously only 33 slides per hour. This includes everything. So this includes loading, slide downloading, focusing, view, acquisition, barcode reading, everything. In the new circuit, also the higher resolution will be available with the objective changer, and you see even higher speed increase because the extra resolution and the previous time was capable of scanning 14 slides per hour, and now we will be able to scan 36 slides per hour. Speed increase with the other objective because with the smaller field of view, with the same stage movement speed, we can grab more field of view, and the stronger PC can also process them, and that's why we have a higher increase in the higher resolution. Okay, we show the new fluorescent slide. So this is the lower fluorescent segment. Then this of the new light source is more stability, but will provide better image quality and better spectrum, longer lifetime, more economical, and it will fully replace the HXD 120, but we will not deliver in the future. So the XP 120 was using metal halide arc lamp, but have several problems. So there is this is coming from the construction of the arc lamps. The first problem is arc lamping. So anode and the cathode, the arc is moving. This is called arc haltering as the arc slowly moves around the electrodes. The other problem is arc flare, and the arc actually jumping from one side to the other. And due to not air but gas convection inside the bulb, so due to the heat, the arc can also move the arc flutter. And all these problems mean so that the illumination intensity is not stable, and the arc is stable, and also the illumination pattern changes always during the slide. This will be a Lumencore solar. So we are using Lumencore solid state light sources for quite some years now. This lamp is using the same technology as the Lumencore spectra. That here the individual channels cannot be switched on and off. It provides full white and white spectrum. We looked at our solid state light sources, and we selected this one based on the light intensity and also the peaks in the spectrum. So how many times can be used in this system? And due to the solid state illumination pattern is always constant during image acquisition. The intensity is always constant. So what are the advantages? If the illumination pattern and the intensity is constant, back field correction of the system works better, and with the back field correction works better, stitching also works better. So finally the digitized slide will be better. Here are the spectra, the HXP 120 and the solar light source. What you can see here, the first peak is the epi illumination. Actually, the solar has two versions. The peak is around 400 nanometers. The 365 nanometers. We select this version because this fits better currently the filter blocks, and also is better for the excitation. And what is that? Here is one peak missing compared to the HSP 120 around 400 nanometers. So the typical usage pattern, using arc lamps, nobody is really using this type of dyes because the doping has a strong emission in this spectrum. And the next what is typically used is either the aqua or cyan type of dyes, which are excited around 430 nanometers, and the also has a strong peak at 430 nanometers. If you see that between 450 and 500 nanometers, the solar has a peak compared to HXP 120, and this peak is very important because the most widely used green dye, the FITs and audience in this spectral range, and the HXP is very weak in this range, so the FITs excitation is also better. If we see that the HXP has two peaks between 500 and 600. So instead of having two peaks, has a continuous high power spectrum, so many dyes can be excited at better quality. And the most important here is that the solar has an extra peak of 630 nanometers, and the has no additional excitation power in this range. And the peak is very important to use sunlight and also other similar dyes in the near infrared, which are becoming very popular recently, and this is a very important update for the dyes that also that with light source. Okay, of course, solar has more than $20,000 of lifetimes. Since it's a solid-based, basically LED-based light source, it's not the LEDs that go wrong. It's more the ventilation, electronics, or something. So if after $20,000 there is something wrong with the lamp, it can be sent back to service, and it can be. One side, the metal halide valve, which is the HSP 120, is 2,000 hours lifetime. And replacement valve, the customer cost around €1,000. The 20,000 hours, the HXP box has to be replaced, what costs €10,000 more. And it's not just the money, but also the downtime. So the customer always has to order the valve 10 times. You have to go outside, change the valve. There is a downtime. But with the metal halide, it's not that for 2,000 hours you got the best quality, and after it quickly dies. But the lamp decreases continuously during the 2,000. So in the 500 hours, first 500 hours is quite okay, but in the last 500 hours it's quite bad compared to the first 500 hours. So this is the Lumencore solving, but customer support. So you don't have to worry about the lights for many years, and they have better quality during that time. Also, in a typical usage pattern, the Lumencore solar because for metal lights to really warm up and properly, it has to be turned on 15 or 30 minutes. For solar, 1 second is sufficient for turn on because the first thing. So the hours in which the system is used is less compared to the HSP 120. The reach will cost the same as the HSP 120 package. The package, the light source itself, power supply, the light, liquid light guide, and the coupler to the microscope. And now deal with the HSP 120. So we'll shape hopefully this one. I would like to talk about the right features of the scanner software in 1.20. There will be an additional webinar covering the confocal system, and then this webinar will also go into more detail about the features recent development is the sRGB compliant color correction, and the color profiles can be selected in some of them. We really below the sharpening function, which was already available for 3D cameras previously for the field range. We have extended focus range for depth scan, and we got full icon. And this is the story using support with new camera and the highest scan. Okay, our monitors manufactured calibrated according to the sRGB standard. Just a screenshot in Windows in the same resolution wizard where you can also the color. You can see here that the default color profile in Windows is sRGB, is also the default viewing color profile is sRGB. Modify raw camera images according to this standard, and this way the images will look more similar to what you can see in microscope compared to the software. So how is there is a slot for scanner calibration? Actually, this is not for digital slide scanner calibration. It's more like for field via scanner calibration. The Intel ICC group is right now working on some sort of standard for digital light imaging calibration, but the standard is not ready yet. The standard, but once the new standard will be ready, we can usually adopt our system to the new standard that we can use that one. So this IP 8.3 scanner calibration target looks like you see on the left. This is an ideal computer generated image, so you see how many color spots have embedded the grayscales are in the standard, and on the right you see how this target is actually mounted on a glass slide. So the glass slide has to be scanned. Then the special calibration software which calculates the color correction values. So based on values, the color correction matrix calculated was applied to every graph field of view. And the sRGB also requires gamma correction. So gamma correction is basically a lookup table. So when there are pixel intensity 10 is not set to the monitor as 10, but there is an actual lookup table here. Is that as you see here on the curve, that the brighter pixels are even brighter, and are a little bit brighter, so the whole image will have a lighter or look. Before selectable color correction profile. The first is the RGB. Selecting this, the scanner will generate RGB compliant. Using this calibration internally, we notice that due to the lookup, many times faint samples don't look contrastful on the screen. And finally, the option that we keep use RGB compliant color correction instead of applying this gamma, we are using a linear gamma deselected so the user can make a choice. Another thing that we included a new color profile is the microscope line. In this version, the colors are shifted toward the yellow or yellowish colors because that they're used to what they are seeing in the microscope. And this microscope, which is using typically Hawking-like, the background is yellowish, and also colors are shifted toward yellow. And this is there is blue and red under both illuminations. Blue is blue, red is red. But more like colors, which are just between green and blue, or between green and red, really the color perception can change depending on the vision. And that's why this microscope-like function, if somebody is referring to to have an image just like in the microscope, we can provide that one too. The legacy mode, which provides the same color as the previous software version. Motivation for this mode was if somebody is really making a study and would like to scan hundreds of thousands of slides in a longer period, and they like to have the same color even after the software upgrade feature, and they can continue with the same colors and gamma curves as the previous software. Here you can see the differences in the images. So here is the legacy mode. So this is all the cycle like the previous scan by the previous software release of the software. And on the left you see the sRGB standard. And due to the gamma curve, the image is more brighter or lighter, but faint detail that contrast full as in the older version. This is the linear version. On the right side, you can see that we have the colors. If I switch between two legacy mode and you can see that the linearity and the lookup table of the system is the same, so the contrast is the same. You can see the different colors before and after the new calibration. So the microscope-like mode, you see here is more yellowish background, which reminds of the microscope use. Yes. So the color calibration standard also defines a way to measure error, the less of the color calibration. So the international scanner contest in 2012 in the color fidelity category, only the Olympus ES1 scanner was the best, and measured delta error value. So what is the range of the color differences between the actual scan and what should be in the standard. So they won the contest having an error value of 7.7. Another calibrating was 4.9 error value. The lower value is better. Okay, the current software need a general global calibration of systems, so all the systems are using the same type of calibration. Here we will make available functionally this calibration slide, so everybody can buy a calibration slide, and we will make available also this calibration software and release the scanner on site as frequently as they want. So refactoring and reworking of the color processing of our software. We could also make available for the 80-15 grade camera, which is available on the Pannoramic desk, also the sharpening function. So to see how the image looks scanned on a desk with the speed grid without sharpening, and to see them in the new software release on the same system with the same camera. Extend focus range. A year ago, we have hardware to have a larger focus range. So previously, the desk VDN scan had 0.2 millimeter focus range, and the P250 had 0.4 millimeter focus range. All scanners have 0.4 millimeter focus range. In the previous software version, we had only a, let's say, upgrade or an extension to support these hardware changes, but now the full support of the hardware changes is in the 1.7 release. Just I have to summarize quickly the difference on the website. The focus is mechanics and the one same in the P250. motorics is the same as in the task 3D scan. The parallelogram is the same as in the 250. The systems here can be also upgraded to the larger focus range. Okay, it has new icons as well to over software. On the left you can see the other icons, and on the right you can see the ones. So colors are a bit nicer. The images are a little bit more sophisticated. So thank you very much for your attention. To cover this webinar.
Can I ask a question?
Yes.
My voice is active. So first of all, thank you very much, everybody who participated in this meeting. I would ask our colleagues to open let voice communication free for everybody, because we would like to hear your questions. So we can all the Victor, you mentioned color calibration, and I used to meet many times with partners, especially who are dealing with software and considering some other scanners to use. And the color calibration, how it's important for those partners who are not just dealing with software, but they like to do this kind of estimate over. So the user scanner, which color, I think the best we would have for those clients who are working with scanner vendors, because it will have probably to make their software diagnosis application get approved by the authority.
Yes, it's an important question. Is working for some regulation of the scanner. The final is not out yet, but it looks logical that the color calibration is an important part. If we have the capability to apply any sort of color calibration systems, can always be calibrated in the eye. They get important steps for detonate any sort of activity.
So my second question to see that, you know, if somebody is going to visit an exhibition or maybe meeting with customers, many times we can hear that almost the scanner vendor are saying that, oh, this is the best scanner of the market. So we mentioning any name and competitor, just can you position that what you mentioned is in the market in terms of speed? You mentioned that increase the speed comparing to the flash speed. Right. Can you say a couple of, you know, something to fit?
I think currently this is the best scanner on the market for the exploration.
And about the difference between the field of view scanning and linear scanning, because many people are also mentioning this important information that okay, maybe this is a very fast scanner, but this is not doing line scanning, and sometimes we have the feeling that this is not the this is the advantage of the system, that we are doing the field of view scanning, because in case of HISTECH, pixel focus, but even more in case of HISTECH, when you are changing layers, in case of field of view, you can get a steady picture. So we can talk about those samples just to emphasize all those different.
Yeah, the advantage of the area scanning. The really big advantage comes in fluorescent, okay, right? Just the fluorescent top the page. If we are doing a HISTECH, then all the layers will be perfectly pixel pixel precision aligned. In line scanning, this is not possible, so all the different layers are required during a different run, and there is always a few micrometer shift between these runs. If you are changing the focus or the field into you see the cell moving around a few pixels. And more software has the capability to extend this focus, which is creating from several layers one artificial layer where everything is sharp. And this is way low if we have pixel localization. Yeah. There's no localization. This feature is not possible with the line scanner.
All right. And my last question would be that if there are a competition or if there are standard every kind of vendor like are for the product or the capability that features, but what's the big difference in terms of each one box versus everybody very good features, different box. For example, a motor scanner is doing very nice quality and doing very nice resolution. So everybody is claiming that they have that resolution and that quality. And also they have scanners which is almost as speed as the best scanners of the world, but definitely the scanners cannot do both the fluorescence and so the benefit. What is the main benefit in terms of everything is in one box in all cases?
In my view, in this case, the big benefit is price and performance. Because if somebody buys different boxes, they buy 3 stages, 3 housing. So almost everything is done just to have a little bit different functionality. And in our case, if one system is capable doing all functions, with a lower investment, they have the same capability. And I think if field performance is very important, and I think that's the advantage having everything.
So very good. And now it's the time to question from this to anybody.
So, I see the chat box. So put already the question. So why do we compare the solar versus the HXP? It would be interesting to get a comparison solar versus spectrum. So comparing these two solar positives, so we have two different fluorescent light sources. Spectrum is clearly better than the speed, and although for the lower price version, so that's why I emphasize in my presentation that the solar price will be the same as the HXP, but the solar still have better speed. But the solar is less capable as the spectrum. The spectrum is that can individually switch on and off the different channels. So this way I use multi-band filters without changing the filter of the filter wheel. This is not going to be possible with the solar because using solar, all lamps are always on, just like with the metal halide lamp. The other thing is that for the spectrum, we connect directly the camera and the light source. So the camera is triggering the light source, and the light is switching on only for the actual time of exponential emission. And it is possible. A feature will not be available, so it's more to the HXP, and that's why I was always comparing the HXP and the solar because it replaces HXP for the same better features, but not reaching the feature set of the spectrum. What is available for all our scanners? Put your question. receive any questions either in the chat box or the microphone. If there are no other questions, then I would like to thank you for your participation and your time, and I would like to share my day to everybody.
Can somebody, gentlemen, just to ask one question, just to hear that the voice communication active in both directions, so we would appreciate that if one participant asking something in the microphone.